We are back, continuing our journey through the code of this air traffic control game that was sent in. I'll have the video where it all began linked up there. Basically what we've done so far is like a brief overview of how the game is actually structured together, and then also we spent quite a while talking about the resource manager and singletons and globals, so much so actually that I made a complete video dedicated to talking about why I don't like singletons and how, in my opinion, you can adapt them to be a little bit better without getting rid of them entirely. So if that is interesting to you, check out the video linked up there. But today, I really wanted to dive back into all of the code that we have here, because one of the interesting things about this game specifically is that it's actually pulling real world data from the internet, specifically the actual real world aircraft that's inside the airspace that you choose, as well as weather information. And so let's dive back in. This is the main file. Let's go through it. We'll kind of do a bit of a recap and see where we're at. Now, first of all, this resource manager init stuff and this G resource manager, talked about this actually in another video. I've made so many videos about this code base. I'll have that one linked up there as well. So some parts are slightly different from the original code, but if you guys want to follow along with the original code that was sent in, I'll leave the GitHub repository as a link in the description below as well. Okay, so resource manager stuff aside, the first real state that we push in here is this thing called a menu. So let's kind of take an overview of the menu. That's like the first state. I did talk briefly about the state machine in that first video, because everything over here is basically inside a window, which is stored inside this like state machine. So you can see the state machine over here is just a bunch of these states, right? Which are windows. And there's many different kinds of windows. Things that honestly don't really sound like windows, like game is actually a window and menu is a window. And that's why when we run this game, you can see we have this like separate window, and then you pick like a country or a region, and this loads is pulling in all of that real-time information. And then now you can see everything's here in a separate window. So that's kind of how this is all put together. So when we create the menu, let's have a look at what happens. Okay, so we've got a whole bunch of flags here, and I guess that's because it has to display this page over here, which has all of these different flags. Again, interesting that they're kind of just hard-coded like this in the C++ code. Generally with games, actually this is just something that people like to do with software a lot, just because it makes things a lot more flexible, and that is to move data out of the code itself. This is actually a question I get kind of often from beginners who don't understand why everything should be data, and why not, you know, have a list of flags inside your C++ code. Nice and easy, everything's great. But the problem with that is that, and this is actually something that happens to people who are less experienced very often, and that is the fact that they kind of have this tunnel vision of just operating in their current environment. What I mean by that is you are in Visual Studio, you are the C++ programmer, right? So what you're doing, your whole world at the moment as you're writing this application is this. It's literally this program. Visual Studio, or whatever IDE or text editor you're using. In fact, IDEs, text editors aside, really it's just more about the code itself. That's the thing that you're manipulating, kind of like Play-Doh. You're forming it, you're shaping everything. And so obviously for you right now, it's very easy to just be like, I'm gonna expand on this and add, like, France is already here, damn it. Had to pick the one country that's here, Germany or whatever. Let's just add this here. That's really easy. And you're right, it is easy. F5 and suddenly, you know, we've got another flag there, supposing that the actual, I guess, resource it's trying to load actually exists. But the problem is that there's more to life than C++ and Visual Studio and this current environment you're in. And so the biggest problem with this specifically is that the program itself, the binary, the exe that you are compiling is actually dependent on data. And if data changes for whatever reason, you have to literally recompile the entire binary. Now, full disclosure, you know, I'm not trying to over-engineer this or anything, but in this given case, it's not the end of the world, obviously. I mean, this is clearly how this application already works, and it does work. So I just want to be clear, when I talk about things like this, I'm more so trying to perhaps help those of you who are less experienced realize and understand a little bit more of how, like, I guess the real world of professional software might work at a larger scale. And something like this you wouldn't typically find in the real world in like a real big kind of professional production, because, well, I mean, if we really get deep into this, I think that at the end of the day, it kind of comes down to the separation of disciplines. The people who would be in charge of, say, producing these flags and countries and ultimately, I guess, designing the game are usually separate from the engineers who are doing the programming. And thus, instead of like a designer or someone having to go up to an engineer and be like, oh, hey, by the way, can you just add Germany to the list of flags in the code somewhere? You know, because obviously the designer wouldn't be going into the the C++ code and programming stuff. Instead of that happening, the engineers would engineer the system in a way that allows the designers to actually, add or remove flags and like various other pieces of data here from within their own tools or whatever environment they're comfortable with. And then the C++ code, that kind of core engineering, would just be able to handle external data that's sent its way. And that way, these two disciplines, the engineers and the designers, they can live in harmony, in parallel, and basically not step on each other's toes. It's just a smoother production experience all around. In smaller scenarios, such as potentially this, it might just make more sense because, again, you don't have to recompile the binary. You don't even have to open Visual Studio. You could have some external, I don't know, like a YAML file or a JSON file or whatever that just had like a list of countries you supported along with like flags potentially. And then it would be really easy for you to just add another country along with the flag, maybe some information of where to pull like air traffic or map data or weather data from. And suddenly you're okay without having to like open up the actual C++, files, edit like a bunch of them in different places for all these different pieces of data, and then recompile the entire binary and then update it as a separate release, I guess, on GitHub as well, having people download that extra exe instead of potentially, because the other thing is you could easily just pull this list online, right? So if this list was in fact like external data along with all of the details that go along with all of these like countries, then the next time you actually start up the game, you could just pull the updated list as like an external little YAML file, a few kilobytes or whatever, probably less than a few kilobytes even. The game client could just pull that from a server and suddenly that's it. They've got all these new countries. But if it's baked into the exe, like it is here, then again, a developer has to go in, change it, test it, I guess, recompile it, and then ship a new release of an exe that people have to then download to actually play the updated version. And that's just not optimal. But on another note, speaking of things that are optimal, let me introduce you to Brilliant.org, the sponsor of this video, that can greatly help you get started learning programming with their 30-day free trial. Now, for those of you who haven't heard of Brilliant.org, it's an amazing website filled with lots and lots of really high quality courses on various STEM topics. As I mentioned, getting started with programming. Instead of diving into a specific language, learning all about the specifics of just that, Brilliant has another approach which I really like, and that is teaching you how to think like a programmer. And not doing that in a boring way, but actually getting you to engage and interact with the course, such as over here in this lesson, for example, you'll have to drag these in to control the flow of your program. And then once you've got the basics down, you can progress onto a real programming language such as Python. But again, with that kind of visual, engaging, interactive way of learning, which I think is just so effective. And then moving on to math. Who could forget math? So important for programming and so much easier to learn with Brilliant's way of teaching. Because math and visual learning just go together so well, especially for more advanced topics such as calculus. You can see you have these widgets you can drag around to see how the numbers actually affect what's going on. And then of course, getting quizzed every step of the way to make sure that you're actually learning and retaining the information. And as I mentioned, you can get started for free because Brilliant have a 30-day free trial that you can use to check out their entire platform. Just go to brilliant.org/the Cherno. Link will be in the description below. And that link will also get you 20% off an annual subscription if you do go on to enjoy it. Huge thank you as always to Brilliant.org for sponsoring this video. All right, so let's get past these flags. Just wanted to point out the fact that, when I see data baked in like this, especially, coming from someone who develops game engines, because game engines are not specific games, nothing really can be baked in. I mean, of course, you could kind of have data that's relevant to the engine itself and picture the engine itself is the product. And obviously you could bake in that data, but because an engine is a platform upon which you develop games, clearly the game data is all external. So I'm like, I guess, really used to this kind of thing and, well, not doing it this way. Okay, so going down here in the menu, we have this texture, which we trigger a load from over here. So I guess we go through all of the flags. So we got like, how many flags here? 10. We go through all of the flags and we load all of the textures over here inside the menu constructor. Now that's immediately not good to me. Like that immediately raises a red flag. And the reason why, just having a look at how this works, and yeah, it looks like it just goes and actually loads the image. The problem with this is that this happens in the menu constructor. And I'm immediately picturing the menu being constructed more than once. Because what happens if you launch the game, it obviously opens up the menu, you play the game, but then maybe you want to go back to the menu because you want to select like a different country. So I don't know if this game actually supports that, but if it did somehow, then, the logical thing to do, I guess, would have this menu instance probably die when you close that menu window and then you open. In fact, I'm sure it does die. If we have a look at like this state machine, then let's see what happens. So yeah, we have states, which is, remember, a shared pointer over here. I'm guessing this shared pointer inside this stack probably contains really the only live instance of that particular window, because this is, even though again, it's a shared pointer, so it's really hard to tell who owns shared pointers because well, they can be shared. And current state also is sharing that. It might be shared in other files as well. Again, really hard to tell. But because we take this current state, we obviously pop it out of the list, which is going to kill, the shared pointer that's inside this list. Current state still has it though, up until another state actually gets selected, probably because it's going to loop through this, because run, I guess, is going to end because you've closed the menu. It's going to loop back, it's going to get the next state. So this pointer gets overridden, which means that that's probably, this line here is ultimately what's going to kill the menu. So the menu does in fact get destroyed, which means if you want to go back to it, you have to recreate it, which is fine. It's normal to do that. I wouldn't expect the menu to just be alive necessarily during the entire course of the application, just in case you want to go back to it. Sure, kill it. But the problem is when you make a new menu, you're then going to go through here and load all of the flags again, which, just to be clear, isn't necessarily bad. It's just something that is kind of like, oh, that's the side effect, right? The reason why it's not necessarily bad is because you could be like, okay, well, whatever, I'm playing the game. I no longer need the flags loaded in memory. Why don't I unload them from memory? And then obviously when I make the menu again, then I'm going to suddenly need the flags. So yeah, I'll just load them from disk again. These textures are obviously stored as an array of textures inside here. And I'm assuming that, when this object dies, this is the texture destructor, it's going to actually, it's going to delete it from GPU memory. And I'm guessing when it loads it, it probably, once it gets it onto the GPU, it probably deletes it from CPU memory. So it's not like you're leaking textures. It's not like there's anything necessarily that bad about this, but you just have to be aware that, do I want to load all these textures, all these flags every time that I open up the menu, or would I rather have them persist inside the resource manager? And for a game like this, I would probably just have them persist, just because I think, loading this many individual files, especially as PNGs, which are likely compressed, might take, I don't know, a few hundred milliseconds, maybe. That's probably too much, to be honest. I don't think it would take that long, maybe like 50 milliseconds for all of these. You know what, let's actually do this. I should time this and see how accurate I am. Okay, so I was a bit lazy and just stole this timer from Hazel. So let's just, there's a lot of stuff that happens here, but maybe from like around here, let's just start this timer. And then the way this works is I just need to pull up the elapsed milliseconds and we'll just log this like over here or something. And we'll see how many milliseconds this actually took. Okay, never mind. 16 milliseconds, and that's in debug. So I am greatly underestimating the power of my computer. Okay, so I'm just launching it in release, and it's 20 milliseconds. But it was like 16 but it was 12 milliseconds. Okay, well, whatever. I'm guessing it's gonna depend on like probably the disk and whatever, how quickly you can read them. But anyway, it's pretty low. 20 milliseconds is about one frame-ish. 16 milliseconds is one frame if it's 60 FPS. What I want to point out here is this is what you do though, right? You don't just make assumptions like, oh yeah, that'll take a few hundred milliseconds or 50 milliseconds like I just did. Instead, you grab a timer and you actually benchmark it and you actually see, okay, is this a problem? Because you could spend a lot of effort engineering this differently, right? Like we could have the resource manager cache all of this or have some caching system. We could maybe decide that we should like put all of these individual flags into one, like sprite sheet, texture atlas, so that we can just load like a single file. We should maybe have our own texture format, that isn't PNG and isn't potentially compressed. This could be not compressed, by the way, which is maybe why it's taking less time. They're also pretty low resolution images. I think maybe they're 50 by 30 pixels or so. It's probably about right. But anyway, they're pretty low resolution images as well. Wouldn't take too long. We could spend a significant amount of time making this faster, but the question is, do we need to? And unless you're doing it just for your own enjoyment, like, optimizing it, making it as fast as possible, and for, for your own learning experience, it's better to just check. It's better to just be like, okay, is this a problem? Clearly not in this case. So we don't have to worry about any of this. We don't have to worry about, but we have to recreate the menu class if we go back to the menu, which means we have to load all of these images again. That's clearly not an issue unless we expand this to have like 10 times as many flags, which even then would maybe take like half a second to load if it scales linearly like this. Okay, anyway, moving on. Let's get rid of my timer class, setting the position of all of these buttons as well as like the background. But what I'm interested in is what happens when we actually click on this. So we have check hovers, which I guess will go through all of these buttons. So the buttons are, so there's 10 buttons, one for each flag. They get drawn over here and they get created over here with the button and the actual flag string, I guess. And then if the mouse basically is just inside the region, we'll have a white outline showing that you can click on it. And then over here in the handle event, we'll poll the, oh, okay. So this actually has the window. Well, this is a window actually, remember? So it's going to poll the event inside handle event. Yeah, see, this is annoying. And this is also why, like, I'm not the biggest fan of this design either. What I would have done is, I think inside window handle event, I would have just had this collect all of the master events. And then, you know, for each of these, sure, like you could have like an event that's core to every window, such as the close event, be handled here and break. But then if you had something like, you know, a key being pressed, I would stick that over here, but then like create an event object, for example, and call on event with that, you know, in this case, I guess it would be a key pressed event or something like that, right? And so that way you'll have a function that you can override that is basically an on event function with a whole different variety of events that you can then dispatch based on their type and handle like individually. So for key pressed, you can do what you need. For mouse button pressed, you can do what you need. It just makes the, I guess, client side of the code a lot cleaner. So by client side, I mean menu is the thing that is using this core window system. So we can abstract away the details behind like polling events from the SFML window or whatever to the actual kind of higher level version of, hey, you got an event, what do you want to do with it? And I think that would just be better than, because this also results in a lot of duplicated code, right? Like, I mean, one example is window close. Window close has to be written in every single class that is a window, even though it's written in the base class. And same thing with this whole like while loop of polling events. If we go to like the game, which I think is also a window, and we take a look at the handle event, that's also going to have poll event, and it's also going to have this window closed event, right? And the thing is, you can't call the base class and just be like, hey, I actually don't even know if this is a virtual function. It's probably not, because that's not working. Oh, it is. Okay. But it's inaccessible inside window. Yeah, so it's private for whatever reason. Okay, sure. Bit weird, but whatever. If it was protected, you could write this code and it would call the base class's handle event. But the problem is that would mean that when you loop through all of this, because this is a while loop, while there are events to poll, you would have obviously consumed all of the events right here inside the window handle event while loop and only responded to the one closed event that you actually needed to, that was core to like all implementations of window. So yeah, I would just bring all of the polling events, all of the event handling over here, and then use this as a way to like dispatch basically a virtual function that will be on every window called on event with the appropriate object to represent the specific event that happened, and then it would just handle that. To show an example of what I'm talking about in Hazel, we use GLFW, and you can see that we have these callbacks instead of basically polling, you know, this like stack of events basically and processing all of them. I guess it's more of an event queue than a stack, but anyway, instead of doing that, we have these callbacks that GLFW lets us set, and you can see that, for example, for this window close event, it creates a window close event, which is just like a type of Hazel event basically, and then it will call this event callback that's in data, which is really just, anyway, it has to do that because this doesn't have access to the class. But the point is, we're creating this like specific event class, you know, object that encapsulates all the data for that specific event, and we're sending it into the callback. Same thing for like keys. If you press a key, you can see there's a key press event that gets sent there. The release, same thing, repeat events, like whatever. And then inside a place way further down, like this is the editor layer, which represents the main layer for like Hazel's editor. It has an on event function that will receive this event. And then over here, we have this event dispatcher, which will take in that event and dispatch it based on its type to a different function. So if it's a key pressed event that we received, it will call on key pressed event. And then that already is a key pressed event that we can do the appropriate thing with. So that, in my opinion, is a lot cleaner. And of course, there's no duplication. Okay, so back to this. So if we do in fact click, and I guess we're within the region, so there would be something here that would basically loop through, in this case, all of the regions. And if it contains this, so yeah, this is another thing where I'm like, well, you know, if we click and we're within a region, this has to go through all of the regions to see whether or not we clicked within there, which is okay, I think, because again, this is only happening on mouse click, but we're also already doing that here. So this is another thing where it might be like, well, okay, if we're in here, maybe, you know, if mouse button pressed, activate button, you know, like you could do that here already, since this is happening every frame. Not a big deal at all, but just something to maybe consider. So then anyway, if we do click on a place that has an actual button, right? So inside our entire window, we've clicked here, for example, that's obviously within the bounds of a button. The button itself is going to be probably first. Again, this is another thing that I don't like. The fact that, so this is like a, what is it? A pair, I think, that was made over here. Make pair. And the way that it's treated over here is when we loop through region buttons, which this is a pair, we're looping through it as just a const auto reference. So what I would have done instead is I would would have used structured bindings here to basically, I gotta remember how to do this, to basically just expand out those arguments. So we have rectangle shape and then string. So let's see how it was actually made here, just so that I know what to name the variables. So button and flags. So sure, we'll just call it button and flag. So then you can do something like button and flag. And then instead of using this region buttons dot first terminology, which is like, oh, first, like what is that? You literally have to go back to here probably to be like, first is the rectangle shape. Okay, so it's the button. Instead of that, you just write button now. And as long as you're in C++ 17 or above, which has structured bindings, then this will work. And then for second, again, instead of this being dot second, which is a bit weird, you would have flag. You'd have the word flag. So it's just a way to, I guess, expand like that pair into actual individual variable names that are within that pair. And alternatively, you could, I guess, still do this within here if you really wanted to keep this loop for whatever reason. You could just do something like region buttons like that and expand it within here if you wanted to, and it's going to have the same effect. All right, so we're going to make apparently a brand new shared pointer over here when we click on this button of this live API. And this live API, I'm guessing, is going to, communicate with the internet based on the latitude and longitude. So probably where we picked, get region box of what specifically? Just M region box. Wonder how this works. Right, so this will be based on a selected region. So the resource manager, which is supposed to manage our external resources, literally stores a member, which is the selected region. Oh no. And I'm guessing that gets set when we want to load a region. All right, and so how does it get set though? Because it hasn't, load region happens here, right? So the thing that happens here is this is just us making an instance. There's no constructor, so it's doing nothing. It's just allocated the memory for it basically and created it on the heap. Interestingly, if mocking is available, we're doing this here. I'm not sure why this wouldn't, have just been something like this, where you would have just had it not created, and then based on this, you would have done one or the other. Not a big deal, obviously, because the constructor doesn't actually do anything, but you are still doing a heap allocation and creating a shared pointer, for no reason, because then you're overriding it. Again, nitpicking, not a huge deal. And then we're doing data fetch set API. So yeah, so the mocking enabled just means that it won't connect to the internet. It will just use like local data or some kind of example data instead of actually making that connection to the internet. So data fetch set API, let's see what that does. Okay, wow, it moves the shared pointer API into there. And then this is static and lives here. Okay, and it's private. Look, when you're doing stuff like this, see, this is what I also don't really love. When you're doing stuff like this, I think that what I would do, because it's confusing for me to go through the effort of creating it within this scope to then just move it, right? Because by moving it, you're invalidating like this shared pointer, and now it's just stored here. So why move it when we could have just constructed it here, right? So what I would have done, just as an alternative to this, what you could have done is you could have just had like, this is a bit more of like potentially a fancier way to do this. You really don't have to do it this way at all. In fact, I probably wouldn't do it this way now that I think about it. But what you could do if you had like a whole assortment of various APIs and a mock API. So a mock API is a live API. Okay, cool. So live API is kind of the base class. We could make a function such as create API, and then that would just do mapi std make shared, and then live API. Instead of live API would have T. And then of course you would, I'm not going to get too deep into templates here, but you would want to basically put in some protection here to make sure that T is live API or a subclass. You could do like an enable if or something like that. This would obviously be static. And then so what that would mean is you'd still have this here, which you don't need, by the way, which is why I kind of came up with a better solution, I guess, while I was writing this. But at the very least, instead of doing all this set API stuff, because this could also call set, well, actually, no, you don't even need to, because set API just does that with the move as well. So instead of doing any of that, you basically just replace your set API with create API, and then it would either be live API, which is what you're doing over here in this line, or obviously you would change it to, if it's mocking, we could just do let's do a mock API instead. So it would be one of these two things. The other alternative is to just have create API without a template like this, and then we could implement this in the actual CPP file. And then all you're doing is you're doing this. You're just saying, okay, well, if mocking is available because resource manager is global accessible anywhere, then we would do like the mock API. But then if it's, otherwise we would do like the same thing, but it's going to be the live API over here, right? So, and then that obviously means that all of this is now just create API. So there we go. That's it. All we do is data fetch create API. Really, really easy. Now, the only thing that I don't like about this is why, like, I still don't understand why this is in the resource manager. Why is this not like some kind of, I don't know, world manager or like region manager, or it just doesn't make sense because like, I guess there are external resources here that are being loaded, but the specific operations that are happening here, like to me, are more part of like gameplay rather than some kind of abstract resource manager that's just supposed supposed to, well, manage the resources of this game. And then we're going to push the game state in. This also is interesting. Why is this done here inside the menu? Why not do this as the first thing in the constructor of game? Because clearly this stuff is related to the game. Is it because flag needs to be used specifically here? But then we could create a game instance with that particular flag, considering that this instance of the game class is going to apply to whatever country or region we've picked at the moment anyway. So basically getting rid of this and just triggering this game, and then up here when we do load elements, load waypoints, there could be something like, I don't know, load or create data fetcher API or whatever it might be. You could do this stuff up here. That to me would make a lot more sense. I also noticed over here there's the window close. This isn't something I would necessarily do here either. I think the state machine could probably handle that, or at least when that state dies, it could probably close its own window. I think that would make a little bit more sense than having that have to happen from within this actual menu class. Obviously, you still need to trigger the fact that this should close, which I don't know. There is a run function. Actually, is there a run function? Where's the run function? There is a run function inside the current state, which would be, there wasn't any inside menu, so I'm guessing it would have to be here. Okay, so it's a while window is open. Well, yeah, I guess since that does happen here, it does make sense to just close the window from within the menu, even though that does seem a little bit weird. Okay, so then finally we get taken into the game class. We create a new window. We have our elements and waypoints that get loaded. So I'm interested in this data fetcher and how exactly it ends up fetching the data. So add new entities. When does that happen? So that happens as part of load elements. Okay, so we load a bunch of different things. There's sounds here, there's texts, random facts, whatever. And then part of it over here is add new entities, which will try and get the arrivals from the data fetcher. So I'm guessing these are the inbound planes to various airports or airfields in that particular region. So if we do get flying entities, then we'll ask again the global kind of singleton resource manager, what airports exist for our particular region, which I don't know where this comes from, if it's from a file or from, so load airports. It looks like airports.txt, it does kind of come from a text file. And then over here on this line, we're going to call into the API to get the flying entities, which for the live API would call get flying entities, which is going to get the bounds, I guess, of what we want, create a latitude average and a longitude average. So I'm guessing what that means is if we have these bounds over here, the bounds themselves are obviously, they kind of make up these four corners over here. But then what we're doing is getting the latitude average, so the middle of this bounding box on the latitude and the longitude as well. So we're getting the center point and then maybe having some sort of radius instead. Oh, look, here's a get region radius. And then if you pump that into api.airplanes.live, apparently you get some JSON data back that I guess tells you who's in that airspace. And so now we have some JSON data. That's kind of cool. Maybe I should make something in Hazel that just has real world aircraft or something. That'd be kind of interesting. This is honestly my favorite part of the game, because you could just, have that mock API and just create your own data, but that's kind of boring, isn't it? Isn't it much cooler to just be you know what, let me pull this from the internet and get the live real world air traffic in that particular region? So much cooler. And so now we have, a bunch of this. So we shuffle this randomly for whatever reason, and then I guess we go through, and this is all just decoding JSON, basically just getting all of the stuff we care about, such as the altitude, the airspeed, I guess their position as well would be somewhere here, the squawk code, the call sign, all of that stuff is pulled out of the JSON data that we downloaded from that API online, and then we push that back into the flying entities. So yeah, pretty cool. The only thing that I don't like about this potentially is just the whole JSON decode situation could potentially be abstracted a little bit more. So what you're pulling out of that particular, when you're going into this live API and you download that JSON data, maybe I would put that through some kind of JSON decoder or some other function that would give me back a struct of data that I care about. That way you wouldn't really need to deal with it all here, just because this really muddies up this particular get flying entities function. The result is going to be the same. It's just a bit of a code thing, and potentially you could reuse that JSON decoder or whatever for other things like the weather. Speaking of the weather, so MAPI get weather textures. So let's have a look at the live API and how it gets the weather. So we've got the get weather path, which gets called from within get weather textures, which is going to go to talcache.rainviewer.com, which is a 404 not found for me, so that's nice. But anyway, here we just have a normal HTML page. So I'm guessing this doesn't currently work since that was a 404. But anyway, if it did, what we're doing over here is creating a oh, well, that actually, maybe that's why. I just tried to access it just through a browser with no post data. So maybe you have to set like specific post data, which is what's going to happen over here. So we're just, I guess, setting like specifically the region of the weather that we want. And then we get some textures back, which is pretty cool. And then those textures get put, yeah, that is really cool actually. So this website will, I guess, provide you with like satellite images or whatever of weather data in the region you request. And so you get like these textures back. And then all we're doing over here is just grabbing those textures. So we get a vector of textures back. We get this list of textures. And then like, where's that used? Over here in weather.cpp, when we do fetch weather images, we're pulling the textures down over here, iterating through all of them. And then we have like these textures and I guess these tiles that get created from this as well. Doing some fancy stuff over here to, I guess, reproject this. Convert lat long to XY position within a bounding box. Sure. And then we just create like these like SFML sprites which have those textures, and we set their position to where they're supposed to be, I guess, within the bounds of our window. So that's really cool. Again, like huge bonus points, I guess you'd call it, for actually using real world data, especially with these like weather textures. I think that's really cool. That's probably cooler than the real world air traffic data, just because the air traffic data is kind of a bit trivial, you know, to do, but this actually seems like it's quite involved. So yeah, like overall, really cool project. I really like it. There's not that much, like I haven't really seen too many bad things, I guess, here. You know, a lot of this obviously comes down to just like opinion, you know, a lot of this is subjective. Architecture code like you want, especially if it's just a project you're doing for fun, that is not of a huge scale and doesn't have to be like some professional version that is shared amongst a professional team. What matters in projects like these is that they work and that they do cool things like pulling this stuff from the internet. I mentioned in the first video that the only kind of usability things that I didn't like was the fact that it's just locked to a 1280 by 720 non-resizable window, and also you can't like zoom in or anything, which obviously means that, you know, when you're playing this, it's just small. Also, I just had the audio actually on when I heard radio chatter, because I think the other cool thing that this does, which we didn't get to take a look at, is it actually pulls like the live ATC radio from, I guess, one of the towers, one of the radio frequencies in that area, and plays it for you, which is really cool. So it's quite immersive, quite a cool experience. So yeah, overall, really enjoyable project. Biggest things I would change are things like the singleton, and just maybe architecting this project a little bit more like a tree when it comes down to ownership. I talked about that in the video that I released about why I don't like singletons. And then of course, there's also the matter of what should be where, because what I've noticed in this project is there's a lot of code, just like random bits of code all over the place. Like for example, the stuff in the resource manager that really shouldn't be there. Then inside the menu class, when we were trying to load stuff, we were setting up like data fetching APIs, which could have been either in the data fetcher file / class or inside the constructor of game like I showed. It just seems like a lot of this stuff is a bit all over the place, makes it seem like some areas of this code are almost like a game jam game. It's just kind of like, I don't have time, so let me just plop this wherever, I don't really care. So I guess having this code a little bit more structured, a little bit more organized, I think would probably massively help when you do scale this up, because it's already getting to the point where I can imagine it's a little bit out of hand and might be hard to find certain things and work on them and extend them, just because everything is kind of like, it's just muddied up. It's all kind of all over the place. Now, if you guys want me to take a look at your project, send it into chernoreview@gmail.com. There will be that email address as well as some instructions in the description below. Thank you all for watching. I will see you next time. Goodbye.